So if you're taking Calculus 1 or if you're a calculus teacher, then this video will be for you because I will show you guys my Calculus 1 quiz number 1 on limits. We have a total of 10 questions. The first 5 questions are multiple choice and the last 5 questions will be free response, aka you have to show your work. And of course, you guys can go download this file in the description and try out the questions along the way. And now let's just go ahead and get started with number 1. We have this limit. The limit as x approaching infinity of this function, and you should pause the video and try the questions before you watch the solution. Alright, here we go. First, let's just go ahead and plug in infinity into all the x's and see what happens. So we have e to the 1 over, x is the infinity, and then we have over 2 plus e to the 1 over infinity. If we can draw conclusions along the way, that would be great, and hopefully we don't run into any indeterminate forms. And notice that I'm putting down an arrow right here because we are doing limits. First, we see that we have 1 over infinity, that will be going to 0. So we can say on the top we have e to the 0's power, and then over 2 plus e, and that will also be to the 0's power. Next, we have e to the 0, which is just approaching 1. And then on the bottom, same thing, 2 plus e to the 0, and that will be 1. So finally, we see that 1 over 2 plus 1 is, of course, just 1/3. That's it. The answer is D. Right? Now, number 2, a little bit trickier because this is actually one of my favorite types of questions to ask students. Which of the following statement is true? Which of the following statement is false? Right? This kind of questions. But here we are looking at which of the following statement is false. We are given this graph and we have to find out which of the statement is false. So think about it first before you continue. Alright, here we go. The first one, it says the limit as x approaching to f of x, and that's approaching infinity. We can see that's correct because we do have a vertical asymptote when x is approaching 2, right? Well, the vertical asymptote is at x equals 2, and the curve is approaching past infinity from both directions. Because notice that there's no plus or minus, so we have to check both directions, and both of them, they do go up to past infinity. This is true. Right, so this is true. Next, x is approaching 3, and we are saying that the limit of that is 4. That's actually false. Because when x is 3, which is right here, well, no. If you are talking about the limit, right, this is the limit, that means we don't care about exactly as 3, all right? We just care about what happens when the curve is approaching 3. It's pretty much the y value of the open circle. This is actually false. But because this is false, so this is actually the correct answer. So I will just say, let me box the answer right here first. This is false. I will write this because the correct statement should have been the limit as x approaching 3 of our function. It's approaching the y value 2. Alright? And this thing right here is the value of the function at exactly 3. So f of 3 is equal to 4. And this is a very typical limit concept that you have to understand. Next, we have x is approaching infinity, and that's pretty much asking for the horizontal asymptote. The y value is 1, that's correct. X is approaching negative infinity, that's also horizontal asymptote 1, that's correct. I know the answer is B already, but I want to show you guys that all the equations have only one answer, and why not go through the rest, right? Okay, lastly, the domain of f is this thing, interval notation, going from negative infinity to 2, union, right, 2 to infinity. And notice that we use parentheses. So this thing right here, it's the same as saying x cannot be equal to 2. All real numbers, but not 2. And that's correct because you see that we have a vertical asymptote at x equals 2. And that's it. Even though here we have an open circle, but as we mentioned earlier, f of 3 is defined to be 4. So S3 is actually defined. So that's why we include the 3 in the domain. So the answer is B. All right, number 3, let's see. We have a piecewise function, and we have to find out the limit as x approaching 2 of the function. So notice that we don't have a plus or minus right here, so that means we have to do both. So let's see. Let's do the limit as x approaching 2 from the left hand side first. If it's 2 from the left hand side, that means x is less than 2, so we'll be using the first. Right, we'll be using the first piece, so that's 4x minus 3. And then let's just plug in. Like, you plug in 2 to find the limit. That's all because there's no indeterminate form 1 now. So yeah. So it's just 4 times 2. You don't have to put down the minus. You really don't. And then minus 3, and that's equal to 5. And then you're done for that. And if you do the limit as x approaching 2 from the positive direction, we use the second piece. So that's x squared plus 8. Well, plugging 2 in here, so we get 2 squared plus 8. That's 12. And as we can see, they are not equal. Therefore, this limit actually does not exist. So be really careful with that. If the positive and negative limits, or the left and right limits, they don't match, then they don't exist. Right? The limit doesn't exist. All right, number 4. This is the one that's slightly more demanding, but just work it out, so it's okay. All right, so I'll show you guys the algebra way to do this. This right here is just the limit as h approaching 0. First, we will have to expand this, and this is just a binomial expansion. 3 plus h squared, we will get 3 squared, which is 9, plus 2 times this and that. 2 times 3 is 6, and then times h. So in the middle, we have 6h. And then lastly, we do the h squared. Okay. Next, we distribute the negative 5 as usual. So we get negative 15 minus 5h. And at the end, we have the plus 6 and all over h. All right, this is the limit as h approaching 0. On the top, we can actually simplify a little bit, because notice 9 minus 15 is negative 6, and along with this 6, they actually all cancel out to be 0, so that's pretty nice. And you see that we have the 6h minus 5h, so together we have an h, and then plus h squared over h. That's all. And maybe let me just erase this a little bit. Let me write it down better. So on the top, we just have h plus h squared over h. And we can factor out an h on the top. So h times 1 plus h and over h. And then this and that cancel. Now we just put 0 in here. So we get 1 plus h is 0, and we get the answer is 1. So the answer is just 1. Of course, I know there's the derivative way to do it. Let's finish this first. I'll come back to this later, okay? All right, number 5. So the limit as x approaching 1, ln of x over x to the fourth power minus 1. And you might be wondering how are we supposed to do this with the L'Hopital's rule? Well, this is meant to be for the introduction to calculus, to limits, right? So the way that we'll do it is use a calculator. I do allow students to use a calculator for this. So I will just set up a table of values for you guys real quick. So let's say here I have the input x, and then we have ln x over x to the fourth power minus 1. And let's just do a couple numbers, and that will be actually enough. So I'll show you. Here's the deal. If x is exactly equal to 1, right? Because we just care about x is approaching 1. So we look at 1, but if you plug in 1, unfortunately, this right here is undefined. All right? This right here is undefined. Let me write it down better. Undefined. So what we are going to do for limit is that we will be approaching 1 from both directions. So right here, I can say this is 1.001, and I say this is 1.0001, or I can go from the left. So this is 0.99, and let's do one more. Right? So 3 decimal places on the left and 3 decimal places, and this is 0.9999. And I'll show you guys the values. And again, just use the calculator. I'll be using that as well. So let's do this one right here. So 0.999 on the calculator, it will give you 0.2505 and so on, but I'm just going to write this down. And the next 0.999 will give us also 0.2505, but there are more digits after this. All right, I'm just not going to write them down because you pretty much know the answer already. Anyway, 1.001, we get 0.2495, and then 1.0001, this also gives us about this 0.2495. Again, this right here, there are more digits, but it looks like it's what you can see that we get 0.25, and that's of course 1/4. So that's the answer for that, and we are done. Number 6. Now we are going to the shorter questions, and here we have this limit. And usually for my shorter questions, it will be worth more, of course. So if you're a calculus teacher, feel free to use this with your students and assign the points whichever way that you would like. But for me, the multiple choice questions are 1 point each, and then for the short questions are 2 points. It's 2 points each. Okay, for this one, if you put infinity into all the x's, I will tell you we will end up with an infinity minus infinity situation. Go ahead and try it on your own. All right. So what are we going to do with this though? We don't like infinity minus infinity. We like to have fraction better. So when you have square roots, let's do the usual business. Let's multiply the top and bottom by its conjugate. So for the top, I'm going to multiply by square root of x squared plus 20x plus 1. And then instead of the minus, we will have a plus here. And then same thing here, square root of x squared plus 8. And then on the bottom, we will have the same thing. So square root of x squared plus 20x plus 1 plus square root of x squared plus 8. And let's just work this out. This is now the limit as x approaching infinity. And here we have, don't multiply on the bottom, just keep it as how it is. And actually, let me write it down better, sorry. It's just square root of x squared plus 20x plus 1 plus square root of x squared plus 8. For the top, to multiply this out, all we have to do is square the first thing. So we just get that because we don't have the, we just get inside because square root and square will cancel. So just x squared plus 20x plus 1. And then we minus the square of the second. So that's just going to be x squared plus 8. All right. And again, the idea is that we're using the difference of two square formula. A squared, sorry, I should have written a minus b times a plus b gives us a squared minus b squared. So use this to multiply out the top whenever we have the conjugates. Well, next, let's see. Distribute the negative, we get negative x squared and then minus 8, yeah? And you see that x squared minus x squared will cancel. So it looks like we have the limit as x approaching infinity. The bottom is square root of x squared plus 20x plus 1 plus square root of x squared plus 8. The top is now just, we have the 20x. And then 1 minus 8, right? 1 minus 8, that's minus 7. Yeah. All right, now we have a what? We have a infinity over infinity case. Okay? X is approaching infinity. You can plug in, you get an infinity over infinity case. Originally, it was infinity minus infinity case. This is much better, and I'll show you guys a quick way to do it, and it's okay for my students to do this. All we have to do when we have an infinity over infinity case is just that we just have to care about the highest power of x on the top and the highest power of x on the bottom. On the top, we care about 20x. All right, that's to the first power. On the bottom, well, we have x squared instead of the square root, so we care about this. That's the highest power of x. Here, we also have the same thing, but make sure that you keep in mind they are in the square root. So in fact, this will turn out to be x, and likewise, this will also turn out to be x. And let me just make a note on the side. When I have square root of x squared, I cancel this and that, right? This right here, it's not really just x. It's technically absolute value of x. However, we know x is approaching positive infinity, so the absolute value right here, it was not needed. So just keep that in mind. So let me just perhaps write this down. When we cancel, we will get absolute value of x, and then again, this right here will turn into just x if x is greater than or equal to 0, but you will get negative x if the inside is less than 0. So now on the bottom, we actually have 2x. And as you can see though, here we will just have the limit as x approaching infinity. On the top is just 20x that we care. On the bottom is x plus x, which is 2x. All in all, we see that the x and x cancel, reduce 20 and 2, we get 10. And that's it. That's the answer. And the reason that we can do this is x is approaching infinity, and we're just caring about the dominating terms. And if your teacher wants you guys to do it another format, then follow your teacher, but you can do it like that in my class. Okay, next, number 7. This is, again, a very standard limit, and we'll just be doing algebra for this, all right? So go ahead and try it before we continue. All right, here we go. How do we deal when we have a complex fraction? Meaning that we have a little fraction instead of a big fraction, right? Of course, we should always plug in 9 into all the x's and see what happens, but I will tell you we get 0 for 0. So the way that we have to simplify this is we multiply the top and bottom by the common denominator, which we have the 5 here and then the x plus 1 here. So I will just multiply by 5 times x plus 1, and we also do the same on the bottom. Okay, this right here is the limit x approaching 9. Don't multiply out the bottom, just keep it as how it is. We have 5 times x minus 9 times x plus 1. And then for the top, we distribute, yeah? Well, the first part, x plus 1 will cancel. So we just do 5, we just do 2 times 5. So we get 10. Next, we have a minus, and then this times that, the 5 will cancel, and we just have a parentheses, this part, which is x plus 1. Now, if you take a look at this, let me tell you guys a super common mistake. When a lot of students see this, they will just tend to cancel the x plus 1 because the x plus 1 is in the parentheses and they are the same. But we cannot do this. We cannot do this because of the order of operation. Down the top, make sure that we combine items and simplify, factor if necessary before we can cancel, right? Because the top is like the whole thing, we have to make sure we distribute the negative and do all that. When we distribute the negative, we get negative x and then minus 1. So we will be getting the limit as x approaching 9. On the bottom is still 5 times x minus 9 times x plus 1. But on the top, we get, well, we have negative x. No, let's write it on this. It depends how you right? Let's write it as negative x, right? Because this is negative x. And then 10 minus 1, which is plus 9. Okay, be careful. How do we simplify this? we will have to factor out negative. So this is the limit as x approaching 9. So we have 5 times x minus 9, x plus 1 on the bottom. On the top, this thing is negative times x minus 9 because we factored out a negative. Now we can cancel this x minus 9 and that x minus 9. And let's see, this will give us no more 0 over 0 situation. On the top is just negative 1. We have 5, and then we just plug in 9 to this x. So we have 9 plus 1. Work this out, we get negative 1 over 50. And that's the answer for that. Now, number 8. We have a difference of 2 cubes. X to the third power minus 1000 over x minus 10. So what do you think what we should do? Done? Cool. We have 2 ways to do it. Some people will prefer to use the long division. Some people prefer to factor. I will do it by factoring, I would say. So here we go. This is the limit as x approaching 10. We have x to the third power, which is just x to the third power, minus 1000 is 10 to the third power, and then over x minus 10. To factor a difference of 2 cubes, well, we first get x minus 10. So I will just write that down, x minus 10. And we multiply this by the first x squared. So we have x squared. And then we will have to add, right? It's minus minus plus. So that's why here we have a plus. Plus. We have to add x times 10, which will give us 10x. And then lastly, we add 10 squared, which will give us 100. So this is how we factor a difference of 2 cubes. And if you guys want more practice like this, you can go ahead and check out my 100 algebra questions for calculus. Or you can also just check out my algebra channel for how to factor this kind of things. On the bottom though, it's x minus 10. And this and that cancel out nicely. Lastly, just put the 10 into all the x's. So we have 10 squared and then plus 10 times 10. And then lastly, we add 100. So altogether, work this out, we will get 300, which is a pretty cool number, I'll say. Okay, let's see. Next. Crazy. What do we do? The limit as x approaching 2 plus, and then we have a fraction minus another one. Pause the video and try it. Or maybe you have tried it already then. Okay, I will tell you though, if you plug in 2 plus into all the x's, we will be getting infinity minus infinity, so we have to do more work for this. And let's just deal with some fractions. Have a look. This right here, 4x squared minus 5x minus 6 can actually be factored. I'll show you with the tic-tac-toe method. So 4x squared can be break it down as 4x times x. And then to break down negative 6, let me use negative 2 and 3. I will put negative 2 right here and 3 right here. And if you check, this times this will give us negative 8x. This times this will give us 3x. Together, we do end up with the negative 5x. Therefore, the bottom here means that we get 4x plus 3. You cross multiply to check, and then you write it across for the answer. So 4x plus 3 times x plus 2. So that's a factoring for the bottom. So x minus 2, that was a minus in blue. Alright, so here we can factor 4x plus 3 times x minus 2. Well, if you look at the first fraction, it has these two denominator, but for the second one, we only have x minus 2, right? So that means we have to multiply the second one with 4x plus 3. So 4x plus 3. And now we can proceed. So here we have the limit as x approaching 2 plus, and I'm just going to put them together as one big fraction. We have 4x plus 3 times x minus 2. On the top, we have that 5x plus 1 that stays the same. And then, don't forget that, be really careful here. It's a minus 1. So we distribute that. So we get minus 4x minus 3. Okay, this is the limit as x approaching 2 plus. On the top, if you combine, 5x minus 4x is x. And then 1 minus 3 is minus 2. And then the bottom is still the same. Quite nice, because x minus 1, x minus 2 cancel. So we have just a 1 on the top. And I'm just going to be plugging 2 into here. So 4 times 2 plus 3. You don't have to put on the plus because we're at the very end. Work that out. You get 1 over 11. Yeah, 1 over 11. All right, number 10. The limit as x approaching 4 plus of 1 over ln of x minus 4. Pause the video and try this first. Done? Okay, so the way that I will show the students is that just kind of plugging. This is kind of like abuse the notation, but it works pretty nicely, I would say. Anyway, here we go. I'm just going to put this in blue. Right? We have 1 over ln of, we have 4 plus into x, and then minus 4. And we'll be drawing arrows because we'll see if we can draw conclusions along the way. So the first thing that we can do is, all right, here, what's 4 minus 4? Yes, I know it's 0, but I still want you guys to say it's 0. However, if you just put 4 minus 4 is equal to 0, that does not tell you enough information. Here we have 4 plus minus 4. So technically, this 0 is a little bit bigger than 0. Let's put down a 0 plus for that. You can imagine this is like 4.001, and then minus 4, you get 0.001, which is just a tiny bit bigger than 0. That's why we have that. If you write this down, then you can see the limits better. 1 over ln of 0 plus. This right here, you can actually draw conclusion. The answer for that is negative infinity. And this is the reason why. When we have the ln graph, it looks like this. This is y equals ln x. And when you put 0 plus, well, it's just a way for you to remember that we're taking limits. When x is approaching 0 from the right hand side, you see that the curve is going straight down. So the limit as x approaching 0 from the right hand side of our function ln x, this right here gives us negative infinity. So that's how we were able to draw that conclusion. Lastly, 1 over infinity will give you 0. 1 over negative infinity, don't say negative 0, it's still just 0. Yeah, so the answer for this right here is equal to 0. You see how earlier I drew arrows because I didn't write down the lim for limit. But here it has a limit already, so I put an equal sign. But anyway though, the answer is 0. Alright, so this is it. This is my quiz for limits. It's like an introduction. Let me know what did you guys get. And before we go, I would like to show you guys 2 questions as I promised. Let's do the derivative one. Let's do which one? Let's do number 5. I know a lot of you guys want me to do this one with the so-called L'Hopital's rule. So again, don't use L'Hopital's rule for this quiz though. If you want to use L'Hopital's rule, this is how you do it. Here we have the limit as x approaching 1. We have ln x over x to the 4th minus 1. Firstly, you check when you're plugging 1 into this x and that x. ln 1 is 0. 1 to the 4th minus 1 is 0, so this is 0 over 0. With that said, we can use L'Hopital's rule because this is a 0 for 0 situation, then by L'Hopital's rule, we can just take the derivative on the top and take the derivative on the bottom and compare. So this is the limit as x approaching 1. On the top, if you haven't learned the derivative of ln x, then this wouldn't make sense. But I will tell you guys the answer. We get 1 over x. On the bottom, once you learn the derivative, x of first power minus 1, the answer to that is 4x to the third power. And then if you plug in 1 into all the x's, work that out. It's just 1 on the top over 4 on the bottom. So the answer is just 1 over 4. So that's it. We are done. Right? So for this one, yeah, we can use L'Hopital's rule, but use the calculator. That was the what's that word? That was the solution that was meant to be. Yeah, but let's see what else can we do. Let's do this as well. Let's do derivative. Because this thing, right? This thing, it's actually in the derivative form. Let me just remind you guys. So let me just put a note. When we have the derivative f prime of a, this by definition, it's a limit as h approaching 0 of f of a plus h minus f of a all over h. And if you match this thing here, right, the limit as h approaching 0 of 3 plus h squared minus 5 times 3 plus h plus 6 over h. This thing represents the derivative of some function at what though? Well, as 3. Why? Because you see that we have the 3 plus h, right? We have the 3 plus h. So that's why it's the derivative of some function as 3. Again, it was f of a, and that's equal to f of a plus h minus f of a. So we have f prime of 3. But we will also have to know the function. I'll tell you where our function, this is the original. The function is, well, look at the big picture. We have this thing squared, so that it's going to be x squared, and then minus 5 times this thing. Again, it has the same input, so that is x. And this number is just f of a, but it's minus f of a. But I will tell you, this right here is the function. Check this out. If you focus on this right here, right? Check this out. Let's finish this. Once we know this represents derivative, we can just take the derivative f prime of x. This is equal to, use the power rule, we get 2x minus 5, and then plugging 3 into this derivative right here, we get 2 times 3 minus 5, which of course will give us 1. And of course, that's the same as what we got earlier. All right? So what's the 6? Well, as I told you, the 6 is f of 3. So check this out. Well, the 6 is technically minus f of 3. You'll see f of 3 equals plugging 3 into the original, 3 squared minus five times 3. Work that out. 9 minus 15 is negative 6. So this thing is technically minus negative 6 for the minus f of 3. All right? Yeah. So that's the derivative. Do you guys want one more? Because I set this up with a lot of derivatives in mind. Yeah, this one is also derivative. I can let you guys figure out what that is. Let's do this, because this is meant to be derivative as well. It's quick, right? So here, again, note, if you have f prime of a, there's another form of the definition. This right here is the limit as x approaching a of the function f of x minus f of a over x minus a. It's pretty much like the slope formula. And now for this, we have the limit as x approaching 10. We have x to the third power minus 1000 over x minus 10. This limit represents the derivative as well. It's f prime of what? F prime of 10. Yes, because you see that we have x is approaching 10, right? And now what's the function? Well, the function is just x to a third power, right? So x to a third power. And now take the derivative by using the power rule. We get 3x squared, and then plug in 10. We get f prime of 10. That will be 3 times 10 squared. And you know it, if we work that out, we will get 300. Of course, it's the same answer like what we got earlier. Yeah. So I think this is it for everything. Let me know what you guys think. So this right here will be the, let me just write down the answer or the solution. Which one sounds cooler? I think I will put down solution. Maybe sounds better. Yeah, the solution. And if you guys want to download this written solution, you guys can check out my Patreon. Right? So I'll provide this to my Patreons over there. That's it. Thanks so much for watching, and then I'll see you guys next time.